So today's actually the last day of working with perms and coms. Then we're going to do a couple on Pascal's triangle and stuff, which deals with perms and coms. So let's just kind of go through what we have looked at already. Now, the fundamental counting principle, when do you use the fundamental counting principle? When you're doing perms, okay? This only works for permutations. The factorial notation is very handy when you're using both the perm and com formula. Now, if you're asking, well, I can do them by inspection, see, they will be able to word a question well enough to see if you know how to use this, okay? Now, the number of perms is in this formula, number of coms in this formula. Remember, when we're doing perms with repetition, divide each one out. Now, what we're going to just get going on now is perms and coms questions, and how do you recognize when to use them? Now, there's also questions that use both perms and coms in the question. Okay? Now, we're going through that for that one question in the diploma that is meant for those students who deserve to get 100 on the test. Okay? Now, people most deserve it to get 100 are the most ones that are prepared. So if you've seen questions before and done questions before that you recognize on the test, it's a really good feeling. Okay? In fact, the best feeling, which I know sounds kind of counterproductive, is when you're actually bored of doing that type of question. I guess opposite, right? Opposite of anxiety is like boredom. So if you are going through it and you're just recognizing every single question, perms and coms is a good place to be feeling that, because these can be a little bit tricky. So let's work with this word right here. Okay, so we have the word poppies, and can be made, like how many different arrangements can be made if there was no restrictions. Now, this is always a good one to do, because if you get no restrictions, then you're quite confident that if you have any with more restrictions, or that have restrictions, that the number should be lower, right? Because you have, let's face it, we get a number out of our calculator and we're like, 14,400. Yeah, I guess. Sounds good, right? That's a lot. This could be a lot, right? We don't really know for sure. So, what often with perms and coms, and well, with just about every question in the diploma, there's at least 2 ways to do every question, okay? So, the book does it kind of in a different way that I would do it, because I like to use the fundamental accounting principle. It makes sense to me. This thing keeps popping up, and I got here today, and my sub had messed up my computer so bad I couldn't even use it this morning. So I was on with downtown. Like, what did he do? Mm-hmm. Yeah, he loved you guys too, so it's all good all the way around. He just wrecked everything that I have. He's a happy guy. Older, younger guy? Oh, yeah? Yeah. Josh, who marks your exams? Who marks your math exams? Yeah. Might want to check into that. Yeah. Okay. So with no restrictions, how do we do this one? How many letters? Okay, don't screw that up. Okay? And I'm talking from experience more than anything. Okay? If you mess that part up, there's a very good chance you're going to get the wrong answer. Now, any repeats? There's 3 p's, okay? So if I was to do this without restrictions, I would just go 7 factorial divided by my repeats, and I would get 840. Now, if each arrangement begins with a p, in other words, if this was a password, and I said, I just used the letters from Poppies, but I just mixed them all up, okay? If you gave me the first letter as a P, does that help me a lot? It does. Basically, I get to take that out of the pool, and I'm just going to concentrate on the next 6. So the one way to do it is to, like, throw it out. It's out of the pool. You've already told me it's the first letter. So sometimes I take these from the mindset that, okay, if I had to actually guess, I wouldn't be messing around with the first one. You already gave that to me. So then, if you take it out of the pool, it sounds bad to say, we're taking the P out of the pool. Shouldn't have been in there in the first place. So we're going to take P out of pool. Okay, so with that said, how would I do this question now? 6 factorial divided by how many p's are repeated? 2. Okay, which would give me 360. Now I would not do this question this way. I mean, I would my second time through because I knew, yeah, we've done these. But this is how I would do them my first time. I would say that I have 7 letters. 1, 2, 3, 4, 5, 6, 7. The first letter has restrictions on it. It must be a P. So I have 3 of those that I could pick. How many do I have for the next? I would have 6, 5, 4, 3, 2, 1. So I do it like almost the first lesson we ever did, but now I need to divide by my repeats still, which is 3 factorial. Now, here's the question. This is the same thing as 3 times 6 factorial over 3 factorial, right? So everyone see how I went from there to there? How does this and this get the same answer? Does everybody see that 3 factorial is the same thing as 3 times 2 factorial? Which would, okay, do you see how you get the same answer? 6 factorial over 2 factorial. That's nice when you do get that on the diploma and you're like, okay, hey, yeah, they both get the same answer. I'll tell you, biggest arguments that will come out of the diploma. People fight about the perms and coms. And let's face it, that's your diploma with 50% of your mark. People get, and it's been a long 3 hours, they get pretty passionate about their way and they will, right? But if you did yours 3 ways to show this, and you can say, okay, but I think you're thinking that the piece could go anywhere, okay? Because that's the thing, you know how we took them as a group? Only take them as a group if they're allowed to move everywhere. Don't take them as a group if, I seriously have to get rid of this. Stop bugging me. Okay. The first two letters are a P. Again, that helps me even more if I was trying to guess your password. So P, P, and then 1, 2, 3, 4, 5. So if I was doing this old school, I would do this 3 times 2, and then 5, 4, 3, 2, 1. These have to be both P's, and then I will divide by 3 factorial. And you get 120. Yes, that would be the, going back to this again, which would make, if I was to do it the other way, I would take this and this out of the pool, leaving me with 5 factorial. Do you see how this turns into 5 factorial? Because this is 3 times 2 times 1, which really is 3 factorial. So those would cancel, leaving me with 5 factorial. And I really like when the students start getting some really different, even ways of thinking about it. They're getting the same answer. They can prove why they had the same answer. And those stick out, right? When you get that in the diploma, you remember that very well. Okay? Now, having on a study sheet is not just get like all the information and shove it on there and that's awesome. It's like, why is this question different from this question? Like C and D. I think C and D would have been nice if they would have said 2 P's are put together. Do you see how 2 P's put together would be very different than the first 2 letters must be P? I would treat them as a group. Now this one, if all the P's are to be together. Now, do you remember how we did these before? If we did this, one thing, and then O-I-E-S. See, with that thinking, I would go 5 factorial, right, times the things in the group, 3 factorial, and then I would divide by the repeats. Now, some people, I think, would just right away go, that's just 5 factorial. Why are you going through this? Well, I'm just showing you that with the repeat way. Or you could just see that's 5 factorial, because the P's, I don't care if you switch them around within the group, it's not going to make it different. Yeah? You're taking all the P's out. No. What are you doing with it? Tell me again. So you would pick that 3 choose 3. Right. Times 5 factorial. Very good, yeah. Okay, so C. Okay, now we got to be ready for ones like, or sorry, E. We got to be ready for ones like this because they challenge us a little bit more. If the first letter is P and the second one is not, again, I think these are way easier to do them by the fundamental counting principle. Order is important. It's a perm, so I can do it this way. So I would go 1, 2, 3, 4, 5, 6, 7. So how many choices do I have for the first letter? 3. How many choices for the second? 4. Why? Because this has to equal P. I should do it below. This one cannot equal P. There's only 4. Now, how many for the next? 5, 4, 3, 2, 1. And then I would divide by 3 factorial. And I get 240. So I'm all for doing it the long way, because the long way is still really fast. Okay? If the way that you understand it is still really fast, that's great. If it's taking you 20 minutes though, and you're counting things out, you're drawing diagonals and you're doing all that, right? Like if I said a 28-sided figure, how many diagonals? And you're like, you know what, I'm good at doing those just by drawing them. Like, I don't need a dumb formula and stuff. Just remember, 10-second question that you're taking 10 minutes on. That is hurting you somewhere else in the diploma. Because the perms and coms, you probably realized even with the homework, it's fast. Yep. Oh, I mean, that happens. It's coincidence, right? Because they mathematically always work. Both of them work out to be 5 factorial when it's done. Okay? But what if they said to you, if the first two letters are P, is equivalent to which other scenario? Right? Just that in the diploma, and you've got your 4. And then one of the options is if all the P's are together. Okay, so that's a great question for the diploma. Calculator's not going to save you, but it'll help you check your answer, because you're going to do the one, you can do the other, and you're going to get the same value. Okay. Now, of class, 5 girls, 7 boys. So we got 5G, 7B. Okay? A committee is to be formed with 2 girls and 3 boys. Determine the number of ways a teacher can choose a committee. Now, if there's no restrictions, like, don't kid yourself, there could be something this simple. Every single unit that we have, there will be one question on each of, did you even show up for class, right? So why not this one? So now at this point, this one should be easy. Okay, how would I set this up with girls and boys? How would I choose the girls? 5, choose 2, and the boys? 7, choose 3. Okay, and that gives you the answer of 350. There are no restrictions there. Now, Johnny, the principal's son, has to be in the committee. Figures, eh? It's not what you know. Yep. Yes. Or else it would change this question. Would it change this question? Yeah. It would change my, yeah. So we have to assume Johnny is in the class. Now, since this is a combination question, I cannot do the fundamental counting principle. That's important to know. So it's how many ways can I choose Johnny? I can only choose him once. Okay? How about the girls? Choose 2. Oops. And the boys? 6, choose 2. If, I think that's an excellent question, because if they did say, if Johnny, who's not in the class, the principal said, I want him on the committee, then that would be a 7, choose 3. Or 7, choose 2. Right? Okay. The answer is 150. Okay. The twins, Peter and Paul, cannot both be on the committee. What are my scenarios? No, no, it would be independent. You can see the arguments in the atrium already. Okay, so let's assume they are boys. Okay, what are my scenarios? Let's talk about it before we even get it down in math. Neither of them can be on. People miss that one. Okay, it doesn't say one of Peter and Paul will be on the committee. It says they both cannot be on the committee at the same time. So we have our scenarios of neither or Paul only or Peter only. Okay. So how would neither be? How would you do neither? So the girls would be 5, choose 2. And the boys 5, choose 3. Okay, that's tricky. So I did 5 because Peter and Paul are not, they're left. Sorry. Okay. Now how would you do Paul only? Okay, so we're going to keep our 5, choose 2. Let's just do that for each one. It's good to understand that that should not be changed. So basically, I'm taking Paul out of the pool. Okay, so there is one Paul. And so the boys would be okay, why 5? Because Peter and Paul, yeah, that's 6, right? Oh, just a sec. Right, right, because you don't have Paul, right now, you don't have Peter. Right? Paul has counted as, so this has to total, like we're thinking this should be 7, but we've taken this Paul out, so that's 6, and then can't be Peter, so then we are down to 5. Okay? And the next one, we have 1 Peter, and the boys would be again 5 C2. And we would add these together because it's OR. And you'll get the answer, 300. Okay, you're getting more to where, because this can be done with the complement. What is, there's one scenario we have missed, right? So it's basically like there's 4 scenarios. We have done 3/4 of the scenarios here. There's one more scenario that is actually the complete opposite, as cannot both. They don't form their own committee. They are together in the committee. So the complete opposite of both of you cannot be on would mean both can be or both are. Okay? So the opposite would be no restrictions minus, well, let's put both on committee. Okay, so no restrictions is right there, 350, we already did it. Minus. Let's talk about the committee where both of them are on there. So then it would be like this, right? And then 5, choose 2, and 5, choose 1. Count it out. Okay, I have 3 boys, I have 2 girls. This gets you 300. Okay. Next. Okay, this is a really, really good question. So just kind of read along with me. We've got David, Steve, and Helen. We're trying to answer the following question. Okay, so here's the question. The students in a school band have practiced 5 pop songs and 6 classical compositions. Okay? For the school concert, they will choose a program consisting of 3 pop songs and 2 classical music songs. If the order of the compositions matters, determine the number of different programs which can be presented. Okay? Now, this is a multiple choice question right here. And they just want to know, like, A, B, C, or D, how would you? Okay? So David came up with this one. He says, do 11P5. Okay, now putting up your hand, I want you to think about it. Is he right or is he wrong? And if he's wrong, why? Yes? There is a scenario in 11P5 that he's got popular pop. That is one of the selections. He has not given us what we need, 3 pop, 2 classical. So Stephen says, I know how to do this one. Do 5P3 times 6P2. Why? Yeah, it says if the order of the composition matters. We go with Stephen's answer. Probably about 70% of the province would go with Stephen's answer. Okay. The problem with this one is that it basically does this. and there is a specific order, they're saying, well, no, it's got to be 3 popular first, then 2. Okay? Now Helen goes with 5C3 times 6C2. What's wrong with Helen? This says no, right? Like, if order's important, you shouldn't be doing combinations. Okay? So, the answer is obviously the 4th one. Now, hopefully you guys do remember this. If one of you gets this question just because of today, then it was worth it. Yes? Because so we're doing, so if you do go over here, it says the solution indicated that they're all incorrect. Determine the correct, okay? So let's do B here so we can kind of look at it. Now B is called, or sorry, this question is called a compound set. What's unique about this one is when I choose the songs, is it in any particular order? If I have 5 songs in front of me, and I know I need 3 of them for the concert, is the order in which I choose them, so they're spread out, classical over there, is the order in which I choose them, does it matter? No. So I'm going to choose them, and I'm going to choose these. I have them in each hand, then what am I going to do with them? I'm going to pick the order. Okay? So, what I'm going to do is I'm first going to go 5C3 times 6C2. Now that I have them, I'm going to rearrange them. How many different ways could I rearrange them? Okay, so I want you to think right now. I'm going to have P1, P2, and P3. Okay, these are not just, I'm not going to put P, 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 because then people go, oh, well then you got repeats. No, those are different pop songs. And these are, then I've got C1 and C2. Now remember, these are not repeats. That's why I'm putting P1, P2, P3. What can I do with them now? How many different ways could we rearrange them? Yeah? 5P5. 5P5 is the same thing as 5 factorial. Or 5 times 4 times 3 times 2 times 1. So you just take this and you multiply it by 5P5. Or 5 factorial. we'll get 18,000 programs. Okay. Now it's awesome when students come out and they say they did one of those on us where you had to get them first, you had to choose them, and then you had to order them after. I got that one. And the people that are mad are the ones that just went for, obviously, Stephen. Stephen is going to be the one because of these words right here. If the order matters, people wham right there. Okay? They're like, oh yeah, that one's dumb. No, well, that one's wrong for sure. I'm picking this one. Okay? So you can see we're A, B, C, D here. Great question. And hopefully you remember when you get there. So we're doing 1 to 20, all of them. Again, if you know what you're doing, these are quite fast. Okay, you won't spend a minute a question. You'll spend less than that, and you have 30 minutes. So